Coming up on Destination Tomorrow, a unique ballistic parachute system might help pilots and passengers potentially survive a catastrophic accident. And we visit the Andøya rocket range in Andenes, Norway, to find out how NASA is investigating the Northern Lights. Plus, we'll take a look back at how NASA research helped change the shape of America's air superiority in World War II. And Johnny Alonso finds out how air traffic controllers keep a watchful eye on our skies at all times. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien, and welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
The Northern Lights are a celestial phenomenon that have amazed people for centuries. The scientific name for the phenomena is Aurora Borealis, which is Latin and translates into the red dawn of the north. Although they are incredible to watch, the particles that make up the auroras are actually a type of electricity that can cause electrical surges and disrupt satellite operations in space and communications here on Earth.
To better understand these problems, NASA has been working with researchers and engineers at the Andøya rocket range in Andenes, Norway. Sophisticated rockets are launched into the atmosphere to collect valuable data that might explain the secrets of the auroras.
Jennifer Pulley spoke with Dr. Sten Odenwald at the Andøya rocket range in Andenes, Norway to find out more. The Aurora Borealis, or Northern Lights, is one of the most beautiful, natural occurring phenomena known to man. These shimmering currents of light, which are normally seen near the Arctic Circle, have intrigued and inspired observers for thousands of years. Until the late 19th century, many still believed that the Northern Lights were driven by supernatural means, rather than by natural means. Although these old beliefs are intriguing, we now know that the auroras are actually caused by energized particles colliding with the Earth's magnetosphere. Until recently, the auroras had little direct impact on life here on Earth. But with almost every person on the planet now relying on satellites and electricity as part of their daily lives, the need to understand auroral activity has increased. This is because those same particles that collide with the magnetosphere to create the Northern Lights can also severely damage important satellites and cause outages in electrical power grids around the world. In an effort to better understand these events, NASA is using innovative technologies to learn more about the Northern Lights and how they affect us here on Earth. I spoke with NASA Goddard's Dr. Sten Odenwald here at the Andøya rocket range in Andenes, Norway, to find out more.
It's a very complicated process that leads to an aurora. Once you see it, the whole process is sort of hidden from view. You know, we understand a little bit about how the particles get from the outer parts of the magnetic field of the Earth and into the atmosphere, but we don't see the details, you know, how the particles go from one kind of a system into another, how they get boosted in energy. Even at this late stage, we don't exactly know what the particles are that produce the aurora. Tracking them from where they're produced and where they're energized all the way down to the atmosphere is still something of a mystery, and that's why we have satellite and rocket experiments that are trying to fill in those missing pieces of the puzzle.
To understand why it is important to study the Northern Lights, we must first understand how they work. The sun is constantly emitting streams of electrically charged particles in all directions.
This stream of charged particles is called the solar wind. Since the sun is 93 million miles away, it takes about 3 days for the particles to reach Earth. As the solar winds flow by the Earth, it causes a disturbance in the Earth's magnetosphere. This disturbance energizes currents of particles which are steered by magnetic forces towards the Earth's poles. These energized particles collide with oxygen and nitrogen atoms in our atmosphere, which produce the colorful light that we see in the aurora. Although beautiful to watch, these currents of particles are actually a form of electricity, which can generate up to 800 gigawatts of electrical power. This electrical energy flowing in the upper atmosphere can cause currents to flow in the ground, producing disruptions in communication, electrical outages, and fuel leaks. The high-energy particles flowing in space that often accompany these storms can also hit satellites, damaging their sensitive electronics and creating false commands. This can wreak havoc on television, pager, and other communication services here on Earth. NASA researchers hope to find new ways to predict not only when these storms will hit Earth, but also hope to find ways to reduce their destructive effects when they do.
What are some of the tools you use to study the northern lights?
We have satellites that seem to be able to look at everything that goes on with a solar storm and the production of aurora, literally from cradle to grave. We have satellites that watch the solar surface for the big leaps of matter and energy. We've got satellites that look at the wind in between the planets to watch what that's doing. We also have satellites that are in tighter orbits to the Earth so that they can look at the poles of the Earth and see the aurora happen. They can also measure electric fields in space and magnetic fields in space. So they can also see the invisible flows of particles around the Earth. And then finally, we have rockets that go up into the aurora from the bottom at the same time that the satellites are passing overhead. So we can kind of see the physics in between, flows of particles inwards, and the rockets see the electrical fields that are set up by these things. And we get this complete picture from rockets and satellite observations.
So why is Norway such a popular place to study the northern lights?
It turns out that Norway is in a place that's very favorably located to actually see the aurora directly overhead. So you can launch the rockets directly up very quickly to get into the aurora at the time that they're changing.
Dr. Odenwald, how do you think NASA research is helping us better understand the aurora and its impact on Earth?
Well, NASA's invested an awful lot of time and effort into providing scientists with the technology and equipment they need to really make powerful and insightful discoveries about how aurora work. And that feeds into our knowledge of the environment that we live in space and how that affects human technology, our billions of dollars of satellites that we have there, the health of astronauts because of the energetic particles. It all works together. And if we can deeply understand space weather effects with the help of NASA technology, it's going to be much easier for us to operate in space, and that's the direction that we want to go as a civilization.
Auroras occur around both the northern and southern geomagnetic poles. While the northern lights are known as the aurora borealis, the southern lights are referred to as the aurora australis. Coming up, we'll find out about an innovative new parachute system which is attached to the plane rather than the person inside. But first, did you know that solar flares can be very dangerous to astronauts outside the Earth's atmosphere? In August 1972, an intense solar proton event occurred between the flights of Apollo 16 and 17. If the Apollo 17 astronauts had been on the way to the moon during that time, the astronauts would have absorbed lethal doses of radiation within 10 hours of being exposed.
Currently, there are well over 250,000 active general aviation airplanes around the world. These small aircraft are not only a very popular form of transportation, but are also relatively safe. Unfortunately, about 1 in every 300 of these planes are involved in an accident every year. To make general aviation flying safer, NASA has funded an innovative new parachute recovery system, which, when deployed, may actually allow pilots to walk away from what could have been a catastrophic accident. Tonya St. Romain finds out more.
The sight of small aircraft flying around our skies is a familiar one to most of us. These small general aviation, or GA planes, are favorites of private pilots, small businesses, and flight schools because of their relative low costs and the freedom they provide. Although these aircraft are very safe, about 1,600 of them are involved in accidents every year, and quite often, these accidents can be fatal. In an effort to prevent many of these accidents from becoming fatal, NASA has funded an innovative program which uses a ballistic parachute mounted on the plane, which when deployed can actually save the plane and the passengers from a catastrophic accident. I spoke with Lisa Jones at NASA Langley Research Center to find out more.
Parachute recovery systems are not new. They've been used to return our astronauts from the moon, the Apollo program for instance. They've been applied to the military aircraft such as the F-11 Crew Escape Module. It floats down on a parachute recovery system. Now they're being applied to general aviation aircraft. And in the structural designs, this is a good way to save money and weight because you can actually design the structure to support the parachute system.
The parachute works like this. During an emergency event, if the pilot feels that he's about to lose control of the aircraft or has lost control, he must turn off the engine, then simply pull firmly on the parachute release handle located above his head. The parachute, which is propelled by a solid fuel rocket motor, is released from a special opening on top of the fuselage. 3 Kevlar straps connect the parachute to the airframe and help slow the aircraft, guiding it through a level descent. Although the parachute system already has 155 saves with ultralight aircraft, the first save in a general aviation plane came in October of 2002, with the aircraft suffering little damage and the pilot walking away from the crash with no injuries at all. So Lisa, is this parachute system just for new aircraft, or can it be retrofitted on older planes?
Parachute system design can be incorporated into older aircraft designs. It's just you would have to do some modification to the structure, make sure that the structure could handle the loads the system puts on the airframe, and also be certified for it.
Lisa, what are some situations where a pilot would need to use this device?
As a pilot can tell you, there's many times when things will go bad quickly when flying. So there are many different scenarios where the system may be deployed.
Some situations where a parachute recovery system could be used are loss of control of the aircraft due to icing, engine failure, and airframe structural failure. One of the most common causes of general aviation aircraft accidents is pilot disorientation. Many pilots are only rated to operate an aircraft under visual flight rules, or VFR. But in order to fly in bad weather, a pilot should also be able to fly under IFR, or instrument flight rules. If a visual flight rules rated pilot encounters weather where he can't see visual landmarks outside the plane, then spatial disorientation can occur. When this happens, the pilot literally cannot determine if his plane's in level flight or if it's turning or banking. Very frequently, the VFR pilot will rely on his instincts rather than his instruments, which can lead to a catastrophic outcome. With the parachute recovery system on board, no matter what the situation, the pilot has one last best option to save not only the aircraft, but most importantly, the lives of everyone on board. I know this is being used for general aviation aircraft, but is there a chance that it could be used on larger planes?
I think it can be applied to some of the business jets where you're talking about 10, 12, 14 passenger perhaps. That would have to be really investigated closely. But for application to a transport, you're not going to see that. The structural requirements for the aircraft would be enormous to handle that, as well as the design characteristics for the chute itself to be able to take the energy of a large transport. So you're not going to be able to use this efficiently on anything of much size greater than the general aviation aircraft.
So Lisa, why is NASA working on this type of project?
NASA has a program called the Aviation Safety Program. And in that, we're looking at different types of things to improve safety everywhere. Some of that in the early part of the program was focused on general aviation. There are 1,000 lives a year lost to general aviation accidents. And this type of system can really improve those numbers and hopefully get those down where we see a lot more people walking away from accidents.
When looking back at American fighter planes of World War II, an impressive record of aerial victories stands out. This is especially true in the later stages of the war, when American air superiority dominated both the Pacific and European combat theaters. But surprisingly, this was not the case in the beginning stages of the war. Early American fighters could not always match the speed and maneuverability of the enemy aircraft that they were facing. To help find a way to improve the aircraft American pilots were flying, U.S. military planners turned to NASA's predecessor, NACA, which they hoped could find a way to help the United States gain air superiority over World War II's battlefields. On the eve of World War II, with the prospect of war looming in the United States, military planners began an exhaustive look at the preparedness and equipment that it would use to fight a war. One area where the United States had fallen noticeably behind to its future enemies was in aircraft. Many of the aircraft that U.S. pilots were flying were much slower and less maneuverable than the aircraft that they would soon be facing in combat. With this knowledge in hand, a concerted effort was made by the U.S. government to find ways to quickly improve the American aircraft situation. Since NASA's predecessor, NACA, or the National Advisory Committee for Aeronautics, was the preeminent aeronautics lab in the country, a large part of this examination fell to them. NACA researchers knew that they could improve an aircraft's performance by simply reducing the amount of drag the aircraft experienced. This was called drag cleanup. The Navy's XF-2A Brewster Buffalo was the first of many military aircraft tested by NACA in an effort to improve performance. Researchers at the NACA Langley Research Center took only 5 days to determine several key areas in which the Buffalo could be improved. To the untrained eye, the Buffalo appeared aerodynamically clean. However, the wind tunnel information showed a very different picture. Many parts, like the gun sights, the engine cowling, and landing gear on the Buffalo protruded into the slipstream, causing increased drag which slowed the aircraft tremendously. The researchers at NACA modified these problem areas, which increased the Buffalo's speed by an impressive 10%. Such a performance improvement without raising engine power or reducing fuel efficiency immediately caught the eye of many aircraft designers. Extra speed for a fighter plane, even as little as 15 miles per hour, could determine who won or lost in an aerial dogfight. When Langley researchers streamlined the U.S. Navy's F-4F Wildcat, it was able to fly a full 45 miles per hour faster. The F-4F successor, the F-6F Hellcat, was also streamlined, making it faster and more maneuverable, able to reach a maximum speed of 375 miles per hour. This extra speed proved valuable in combat, allowing Hellcat pilots to destroy nearly 5,000 enemy planes in aerial engagements. NACA Langley proved a key stopping point for dozens of aircraft on their way to combat duty in World War II. During 1 month alone in July 1944, 36 U.S. Army and Navy planes were evaluated in detailed studies of stability, control, and performance. NACA Langley tested 137 different airplane types between 1941 and 1945, either in wind tunnels or in flight. While NACA's pioneering drag cleanup work helped save the lives of many American pilots during World War II, it also shortened the war considerably and saved the lives of countless others around the world.
During the World War II era, NACA researchers also worked on a series of wing designs called the Low Drag Series. These wing designs were so successful in improving aircraft performance that they are still being used by airplane designers today. Coming up, we find out how new satellites may help scientists better understand the Earth's atmosphere. But first, did you know that Charles Lindbergh shot down a Japanese fighter in World War II? Although Lindbergh was not in the military, he was secretly asked to teach American pilots how to increase the range of their P-38 Lightnings. During a training mission on July 28, 1944, Lindbergh encountered a Japanese Sonya aircraft. As the Sonya turned to attack, Lindbergh fired a short burst, sending the Sonya down in flames.
Understanding the Earth's atmosphere can be very difficult. A mixture of global weather patterns, greenhouse gases, and airborne particles can make the overall picture for scientists very confusing. To help provide a better picture of how all of these variables affect the Earth's atmosphere, NASA researchers are developing new atmospheric satellite systems. These new systems will not only work to provide a better understanding of the Earth's atmosphere, but will lead to better prediction models. Stephanie Nevin finds out more.
In recent years, researchers have seen an alarming warming trend in the global climate. Reports of increasing temperatures, thinning glaciers, and rising sea levels have led to widespread speculation that global warming is being caused by greenhouse gases that result from man's activities. Climate models that predict the Earth's future climate patterns indicate that global warming could continue to increase if the concentration of greenhouse gases in the atmosphere continues to rise. Even though these climate models are powerful tools in predicting future global climate, a more detailed understanding of clouds and aerosols could lead to more accurate climate prediction models. Researchers may be able to determine why the climate is warming, if it is being affected by greenhouse gases, and what we can do to change it. That is why researchers at NASA are preparing 6 innovative satellite systems, which when launched will provide key information about the Earth's atmosphere. 2 of these satellites, Calypso and CloudSat, will focus primarily on aerosols and cloud structures, providing much more information about how clouds and aerosols interact with each other and how they're affecting the atmosphere's radiation balance. I spoke with Lamont Poole at NASA Langley Research Center to find out more.
It's important to study clouds and airborne particles, which we call aerosols, because both of them have significant effects on the Earth's climate, just like greenhouse gases such as carbon dioxide. But unlike greenhouse gases, which warm the planet, airborne particles and clouds can either have a warming effect or a cooling effect, depending on their type and their altitude. Because of these complicating factors, it's very difficult to represent cloud and aerosol processes accurately in climate models that are used to forecast the climate in the future. So the data that we will be collecting from CloudSat and Calypso will provide a much more accurate picture of cloud and aerosol processes.
So what are the differences between the Calypso and CloudSat satellites?
They're going to be launched on the same rocket, and when they get to altitude, they will separate into different but very closely matched orbits. In fact, as Calypso and CloudSat orbit the Earth, they will be within 10 to 15 seconds of each other in their orbit. CloudSat and Calypso are going to be flying as part of a formation of satellites that's called the Afternoon Constellation, or the A-Train for short.
The A-Train will actually consist of 6 separate satellites flying in close proximity to one another. Once in orbit, each satellite will cross the equator within minutes of one another, taking specific atmospheric measurements. Although each satellite has a unique mission, the data retrieved will be combined together, providing detailed observations about the condition of Earth and assisting scientists with making predictions related to climate change. By combining information from the different satellites, scientists will be able to gain much more information about the condition of the planet than they could from any single mission alone, greatly improving prediction capabilities. Once these systems are in place, what do you hope the outcome will be?
Our ultimate goal is to provide accurate scientific information to decision makers and governments worldwide so that informed and balanced decisions on how to mitigate or adapt to climate change can be made. And NASA is going to play a very crucial role in this process because of our capabilities in developing and flying new technologies such as Calypso and CloudSat.
NASA researchers are not only studying the Earth's atmosphere from space, but are also making airborne measurements by using specially adapted aircraft.
By the year 2010, the FAA, or Federal Aviation Administration, estimates approximately 1 billion passengers will travel on board commercial planes. As air travel increases, pilots are faced with more congestion on the ground and in the air.
And while pilots are ultimately in control of their own aircraft, it is the air traffic controllers who are directing them the moment the plane leaves the gate, keeping in constant communication as the plane travels en route.
Our own Johnny Alonso finds out how this complex system keeps our skies organized and our planes on schedule.
During peak air travel times in the United States, there are about 5,000 airplanes in the sky every hour, which is about 50,000 aircraft operating in our skies every day. From the time the plane pushes back from the gate until it arrives at the gate of its final destination, it is being handled by air traffic controllers. These controllers must coordinate the movements of thousands of aircraft, keep them at safe distances from each other, and direct them during takeoff and landing from airports. Air traffic controllers are also responsible for directing aircraft around bad weather and ensuring that traffic flows with minimal delay for both commercial and private aircraft. And I spoke with Gary Laurel from NASA Langley to find out how it works.
An air traffic controller is primarily tasked with separating airplanes. However, they do provide other services such as traffic advisories, weather information, and other status types of information for the National Airspace System.
What are some of the tools used by air traffic controllers?
The primary tool used by controllers for separation services is called radar, which stands for radio detection and ranging. And essentially what happens is from an antenna, a radio beam is transmitted, it bounces off the aircraft and is returned to the radar antenna. And there's a presentation on the radar display of which your position is based on that return. You can see behind us there's a display which is part of the radar system that controllers use, and your position as well as the position of other aircraft in the system will be presented on display and give the information the controller needs to provide air traffic services to you.
So, does one controller handle my plane while it's in the air?
There are a number of controllers that will handle your flight as you move throughout the system. Once you depart, your flight will be handed off to yet another controller, and that process continues throughout the duration of your flight. The primary delineation of what a controller is responsible for in a radar environment is called a sector. So as a controller works you through his or her sector, you'll be transferred to another sector where another controller will work you.
All right, so Gary, wait, walk me through this. What happens from departure to arrival, from gate to gate?
Assuming there aren't any delays, you'll taxi out to your departure runway, and there's a controller that issues taxi instructions and deconflicts you from other airplanes on the ground. There's a controller that will issue a takeoff clearance for you, and yet another controller that will work you as you're climbing to your cruise altitude. As a matter of fact, several controllers. As airplanes move from one sector to the next, there's a transfer of what we call control, and there's a transfer of communications, so that you'll be in communications with each controller along the way. And this process continues all the way to your destination airport, and you may talk to 10 or 15 different controllers en route to your destination. Prior to descending into the terminal area at your destination airport, there are several controllers involved in sequencing you inbound to that airport and assigning the arrival runway. Once you get there, you'll land, you'll taxi clear the runway, and you'll be issued taxi instructions. They'll take you right to your gate, but that's basically how the process works.
Wow. And I thought that the pilot was in control of the whole flight.
Well, the pod is ultimately responsible for the safe operation of his or her airplane. Yeah. However, they are required to adhere to air traffic control instructions. Just like when you're driving your car, there are certain signs along the way that basically tell you what you're required to do. As you get to a busy intersection, you may have to slow the car down. If there's a red light, you have to stop because you're trying to accommodate other cars, because you're not the only car out there. And that's pretty much the way your air traffic control system works. Sure. There are control instructions that are issued because you're not the only airplane out there.
Do you get tickets?
Sometimes.
Sometimes. So in the future, will air traffic control be much different than it is today?
I think so. We're of course not building more airports. We're not building many more runways either, so we have to optimize the use of the facilities that we currently have. And to that end, NASA is looking at cutting-edge concepts and technologies to make better utilization of those facilities, both in terms of capacity, that is to say the number of airplanes you can get in and out of an airport at a given time, and safety as well. And these are just some of the concepts that have been explored by NASA and continue to be explored.
Really? I got a question. How do you change the channel on this? I mean, do you have cable on this thing?
That's all for this edition of Destination Tomorrow. Thank you for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.